Picture the moon hanging in black space, bright enough to look permanent, while a tiny rocket-shaped silhouette slips across its face. Somewhere out there, according to tracking predictions, a dead rocket body is moving toward the lunar surface. It has no crew, no fuel plan, and no mission left to complete. It is just hardware drifting through the Earth-Moon system, pulled by gravity toward a final collision. But here is the question that makes this story stranger than a simple crash. If a rocket stage is about to hit the moon, why are experts still debating what it actually is? Online, the moment has been framed like a once-in-a-lifetime spectacle. A rocket, the moon, an impact window, a cosmic countdown. But the sharper mystery is not whether the moon is in danger. It is not. The moon has survived billions of years of impacts. The mystery is how a human-made object large enough to travel between worlds can become uncertain in the records of deep space. The object has been widely described as a SpaceX Falcon 9 stage. That label may be correct, but it has also been treated cautiously because object identification orbital paths predicted timing can change when new analysis comes in. So in this story, we have to separate what is known from what is reported, what is disputed, and what is still speculation. This is not panic, it is not alien mystery, it is a quiet cosmic case file, a dead machine, a silent moon, and a tracking problem bigger than one impact. Before we ask what happens when it hits, we have to ask a stranger question. How did a rocket large enough to cross the Earth-Moon system become a mystery object? The simplest version of the story begins after the launch spectacle is already over. A rocket lifts from Earth, burns through its carefully planned sequence, and separates into pieces. One part carries on with the mission. Another part, often called an upper stage, has done the hardest job it was built to do. It has pushed a payload higher, faster, or farther. Once its propellant is spent, it becomes a silent object following gravity. A Falcon 9 stage, in plain terms, is one of those working sections of a rocket. It is not the reusable booster people usually picture landing upright in dramatic footage. The stage in this story is described as a spent rocket body, a piece of hardware, would have helped send something on its way and then been left behind. If it really was connected to Falcon 9, that makes the label familiar, but it does not make the object easy to follow forever. Near Earth, tracking is more routine. Satellites in low orbit pass through networks of observation again and again. Their paths can be checked, updated, and compared. Deep space debris is different. Once an object is far beyond normal satellite traffic, it becomes dimmer, less frequently watched, and harder to connect with certainty to old launch records. Its motion is no longer a neat circle around Earth. It can be pulled by Earth, tugged by the moon, nudged by the sun, and slowly guided onto a long, looping path that changes over time. A small uncertainty in position or speed can become a much larger uncertainty later. The farther the object travels from ordinary tracking routines, the more its identity begins to depend on reconstruction. That is why this story is more subtle than a simple countdown. The broad idea is factual. Human-made rocket stages can be left moving through the region between Earth and the Moon. Some can remain there for years, following strange paths that are stable for a while and then unstable later. What is less simple is the identity of any one object, the exact shape of its path, the precise conditions of a possible lunar impact. Those details depend on the latest tracking and on how confidently observers can connect a faint moving point in the sky to a known piece of hardware. This is also why the story suddenly feels urgent online. Around the predicted impact window, multiple fresh videos began treating the object as a live cosmic event. Some framed it like breaking news. Others leaned into the shock of a rocket crashing into the moon. But the public data behind the story is thinner than the excitement suggests. The demand is exploratory. The claims need caution, and the most responsible version of the story keeps saying what is known, what is still uncertain. So the lost stage is not just an object on a collision course, it is a test of memory. It asks whether the machines we send beyond Earth remain part of a managed human system, or whether, after their missions end, they become anonymous metal moving through cislunar space until gravity finally gives them a destination. And that brings us to the moon itself. To understand why this matters, we have to stop thinking of the moon as empty. From Earth, it can look like a clean silver disk, silent and untouched. But up close, the moon is less like a blank rock and more like an archive. Its surface has kept records for billions of years because there is no rain to wash them away, no wind to soften them, and no oceans to erase them. Every bright plain and dark basin is part of that record. The moon is covered in old impact scars from natural objects that arrived long before human beings existed. It also holds the traces of exploration, abandoned hardware, landing sites, disturbed dust, and footprints from earlier missions. In that sense, the moon is not only a world, it is a museum without walls, preserving both cosmic violence and human arrival. So when a dead rocket body is reported to be heading toward it, the real question is not whether the moon is in danger. A rocket stage may feel enormous when it sits on a launch pad, surrounded by flame and thunder, but against the moon it is tiny. The moon has survived impacts from natural objects across deep time, many of them far more energetic than a spent piece of human machinery. This event, if the prediction holds, would not break the moon, shift its orbit, or create some disaster visible from every backyard telescope. What it could do is leave a new mark. In principle, a rocket body hitting the lunar surface would be a violent but localized event. The object would strike at high speed, and its motion would be converted almost instantly into heat, fractured material, and excavated dust. Depending on the angle, the terrain, the mass of the object, and whether any instrument happened to be watching from the right place, there might be a brief flash or a plume. There might also be a fresh crater, or at least a disturbed patch of regolith, the fine, powdery layer that covers much of the lunar surface. But every detail matters. The brightness of any flash, the size of any crater, and the chance of seeing it from Earth would depend on conditions, cannot be casually assumed. That is why the careful version of this story sounds less like a movie trailer and more like a scientific puzzle. The spectacle is real in our imagination, but the evidence has to be handled with restraint. This is where the viral framing becomes useful, but also misleading. Some videos point toward the feeling that something rare and irreversible is approaching. But the better story is not simply that a rocket may crash into the moon. Human machines have reached the moon before. The deeper story is that we may be watching the early pages of an accidental debris record beyond Earth. Not the planned monuments, not the famous landers, not the footprints everyone knows. A forgotten object coasting through cislunar space, perhaps misidentified or only partly tracked, may become another mark in lunar dust, and that changes the mood of the whole event. It is not a doomsday scene. It is a quiet warning label. The moon is no longer only being studied from afar. It is being touched, scratched, and archived by the leftovers of our own technology. But the most important part of this story may still be the identity problem. The public story begins with a clean label, SpaceX Falcon 9. It sounds specific, it sounds modern, it sounds like the mystery has already been solved before the object ever reaches the moon. But in deep space, labels can be more fragile than they look. A rocket body does not carry a glowing nameplate that can be read from Earth. Once its engine has gone cold and its mission is over, it becomes a dark shape moving through a huge gravitational landscape. It may reflect a little sunlight. It may appear briefly in observations. Then it may vanish again into the background, too dim, too distant, or simply too low on the priority list to follow every night. The fact layer is that a human-made rocket body was reported to be on a trajectory that could intersect the moon. That alone is enough to matter. The disputed layer is the exact identity of that object. Was it truly a Falcon 9 stage, as early public descriptions suggested, or could the label change when older launch records, tracking arcs, and orbital histories are compared more carefully? That kind of revision is not the same as a cover-up. It is not proof of secrecy. It is a consequence of trying to reconstruct the past motion of an object that has been pushed and pulled for years by Earth, the Moon, and the Sun. In low Earth orbit, tracking is already difficult, but at least the objects pass overhead again and again. Their paths are monitored because they can threaten satellites, stations, and active missions. Beyond Earth, the situation is different. A spent upper stage can be placed on a long, looping path after it finishes sending a payload outward. Over time, small differences in speed and direction can grow into large differences in predicted position. The Moon tugs on it, the Sun tugs on it, Earth tugs on it. Every pass through the Earth-Moon system can alter the path just enough to make the old trail harder to follow. Then there is the record problem. To identify a drifting object, researchers have to connect what is being seen now with something launched in the past. That means comparing faint observations with launch timelines, disposal trajectories, and mathematical models. Sometimes there may be only a short observing arc, which is like seeing a few seconds of a long movie, trying to reconstruct the whole plot. Two possible histories can appear plausible until better analysis removes one of them. This is why the Falcon 9 label should be handled with care. It may be the phrase that brought many viewers into the story, and it is understandable why it spread. SpaceX is familiar. Falcon 9 is famous. A lost rocket stage heading for the moon is a powerful image, but the deeper mystery is not about branding. It is about attribution. When humanity sends hardware beyond easy reach, who keeps the map? Who updates the labels? Who remembers what was abandoned after the main mission was finished? Simpler versions of this story ask only whether the object will crash. That question is dramatic, but it is not the sharpest one. The moon can survive a rocket body. The real revelation is that the space around the moon is no longer empty in the way people imagine. It contains old machines, active missions, discarded parts, and trajectories that may not always be cleanly catalogued for the public. If experts can debate the identity of one large rocket body, what else is moving through the Earth-Moon system without a clean label? That question becomes sharper as the predicted impact window approaches. The story begins to feel like a countdown, not because anyone can promise a perfect view, not because every detail is locked in, but because orbital predictions have turned a cold mathematical path into a moment people can wait for. A rocket body in deep space does not move like an object on a highway. There is no dashboard icon, no tower calling it by name every few minutes, no simple lane it must stay inside. Its path is shaped by Earth, the Moon, and the Sun, and by every small uncertainty that has accumulated since the last useful observation. Predictions can narrow the likely moment. They can narrow the region. They can tell us that an object reported as a spent rocket stage may be heading for the lunar surface. But the final details can still depend on the latest tracking, the quality of the observations, and the assumptions built into the model. That is why the impact window is so powerful as a story. It is specific enough to feel real, but uncertain enough to feel unresolved. It invites live streams, countdown graphics, dramatic thumbnails, and titles that make the moon look like a crime scene. Multiple fresh videos appear because the internet understands one thing very well. People gather around irreversible moments. A volcano beginning to erupt, a wildfire spreading toward a town, a storm making landfall. The subjects are completely different, and this lunar event is not a disaster in the same human sense. But the audience behavior rhymes. When a force is moving toward a point of no return, viewers want to be there when the before becomes the after. Here, though, the expected payoff is stranger. A wildfire is visible. An eruption can throw ash into the sky. A launch produces flame, noise, and a clean direction of travel. A rocket body striking the moon may offer none of that to ordinary viewers. Depending on where it hits, how it hits, and whether any instrument is looking at the right place at the right moment, the event could happen in silence. It could happen beyond direct view. It could become a fact inferred later from orbital calculations, surface images, or the discovery of a fresh scar. And that absence is part of the mystery. The modern world is used to proof arriving as footage. We expect the clip, the replay, the angle from another camera. But deep space does not always provide a clean recording. Sometimes the evidence arrives indirectly. Sometimes the most important frame is the one no one captured. So the impact window is not just a countdown to a collision. It is a test of how we watch the space between Earth and the Moon. Whether the object is finally confirmed as the reported Falcon 9 stage or revised under a different identity, the larger issue remains. More machines are being sent into cislunar space. More hardware will complete its mission and keep moving. More silent objects will need names, histories, and predicted futures. The crash, if it occurs as expected, may be small beside the Moon, but as a data point, it points forward to something much larger, a future traffic system between Earth and the Moon, where losing track of an object is no longer a curiosity, but a problem we have to solve. So return to the image we began with, the Moon hanging in black space, bright, scarred, and almost impossibly old. Across it moves something tiny by comparison, a spent machine, silent and uncontrolled, crossing a world. Has been struck by rocks for billions of years. The drama is not that the Moon is in danger. The drama is that the object may be ours. The clear facts are modest, but they are enough to matter. Rocket stages can be left on deep space trajectories after their work is finished. Objects beyond low Earth orbit are harder to follow than satellites circling close above us, and in this case, a human-made rocket body has been reported on a path that could end at the lunar surface. The label often attached to it is a SpaceX Falcon 9 stage, but that identification, like the exact timing and final details of impact, has to be handled carefully if newer tracking changes the picture. That is the uncertainty at the center of the story, not whether a single piece of debris can harm the Moon in any meaningful way, whether our records are precise enough for the age we are entering. The Earth and Moon are no longer separated by empty imagination. They are becoming a corridor, a region of probes, boosters, landers, planned missions, discarded hardware, and future traffic. In that corridor, a forgotten object is not just junk, it is a test of memory. The speculative layer is quieter but stranger. Future historians may look back on impacts like this as early marks of a debris age, the moment when human activity around the Moon became frequent enough that even accidents needed maps, names, and permanent records. They may not see this object as a disaster. They may see it as a timestamp, a small crater or disturbed patch of dust saying civilization had begun to leave traces even when no astronaut was present and no camera was waiting. That is what makes this a cosmos unsolved story. The mysteries of space do not always arrive as impossible signals from distant stars or shadows moving through alien skies. Sometimes the signal is closer, colder, and more uncomfortable. Sometimes it is a dead machine we launched, used, abandoned, and then struggled to identify as it drifted toward another world. So if multiple videos gathered around the impact window, the real question was never only whether viewers would see a flash. The deeper question was what the countdown revealed about us. Next time we look at the Moon, the oldest scars will still belong to the universe, but one of the newest may belong to us. Continue through Cosmos Unsolved, and we will follow the next strange trace left in the dark.